what is big data? So big data is a problem statement. So anybody says, I know that I have worked with big data would be a far-fetched story, because big data is not a technology, right? Big data is a problem statement. So what is the problem that it defines? What kind of problems big data define? So big data says big data is a collection of all the problems that arises because of the large and complex nature of the data, which can also pertain to ways in which you can process the data. All in all, big data is a problem statement that includes capturing of large amount of data, curation of large amount of data, storage of large amount of data, searching large amount of data or searching from large amount of data, sharing large amount of data over a network, transferring large amount of data, analytics of large amount of data, and visualization of large amount of data. So any problem statement that is associated with large amount of data and categorized under these cases, which is capture, curation, storage, search, share, transfer, analytics, and visualization, can be tagged as a big data problem. So big data is a problem statement that talks about the challenges normal traditional systems fail or faces because of these scenarios. How to capture large amount of data, how to curate means massage the data. If you're talking about loading a large amount of data, a lot of data might not be correct. You want to do a lot of massaging of the data, you want to do a lot of cleansing of the data. They all come under curation. And then storage of the data. Nobody can give you a disk, right? That's what we said. We are limited by hardware right now. So if we have large amount of data and you really want to store large amount of data for analytics later on, that storage has to be provided by some technology. If that is a problem of how to store large amount of data, then you are into a big data problem. And then you have searching, sharing, transferring, analytics, and visualization of the data. All right. So all these categorically are termed as big data problem. All right. So time for another story, guys. Another story. If normally, when I go to the webinar, people tell me, okay, I understand what is big data. You have been talking about big data, defining big data, but from a layman perspective, give me a use case where big data is important for us. All right. Tell me how we can use big data. And things become much more clearer when I tell them this story. All right. Imagine that all of you are the managers of some bank. All of you are the managers of some bank, and for this quarter, your responsibility is to find out the best possible location where you want to set up an ATM. Now, imagine that you guys are the managers, what would be your solution, guys? Where do you set up an ATM? What can be your solution for that? But if I am a manager, I would say, hey, set up an ATM right in front of my house. Every time I'm going to go out, every time I'm going to come inside my house, I'm going to, go and use an ATM. That decision might not be rational. It will be for myself. As a manager, if I want to become a good manager, if I want to make rational decisions, I just cannot, take a decision which is for my own benefit, right? So I cannot make it. So if I have to become a rational manager, if I have to become a manager who thinks about the company, what exactly do I need for making a decision? So guys, what exactly do I need for making a rational decision about putting up an ATM? So you're saying, where less ATMs are present, set up an ATM, where there is a majority of the population, metro station, airport, depends on demand. These are the ways of making a decision. Right? Make an analytics from the requirement. All right, these are ways of making a decision. Perfect. But if I have to make a decision, so let's forget about the bank right now. In your life, in your career, in your personal life, professional life, if you have to make a decision, guys, what do you rely on for making a decision? What exactly is that important thing that helps you make a decision which is rational? Only thing you need to know for making a decision is the actual data, the related data. If you know related data, you can make decisions by looking into the data. The data in personal experience, the data is represented as experience, but these are data also, right? But everything is data. If you have to make a decision, it is nothing but data oriented. So I, as a manager, I go to my bank tomorrow and I call up my analytics team and I tell them that your responsibility is next week, Friday, I want a report where I want to find out the best locations where I can set up an ATM in the city, and that's what exactly you want to work on. So I give that responsibility to my analytics team. Analytics team will go ahead and make a discussion. They'll set up a meeting, and imagine that analytics team is based out of or just team of 5-10 people. They all sit together in a conference room and they start thinking, all right, we need to make a report. We want to make a decision-based report. We need data. Perfect. So they agree that they need data. So now the question is, we know that we need data. where will the data come from? So we have to identify sources of data. Alright, so second phase is identify what the sources of data can be. So what do you say, guys? What can be the sources of data? I would say the first source of data would be my company's own database. I have my customer database. I'm going to pull up my database and find out the data, the customer and their zip code. All right, so data internal to my company. So this is perfect, so I'm getting the data from my company's database. All right, so somebody else in the team says, like what Vyram says, customer complaints. So I'm sure, a lot of people will be, opening up their net banking or opening up their customer care chat window and chatting with the customer care about and complaining about the lack of ATM, right? So yes, I'm going to go ahead and find out logs of customers talking to customer care. So these logs will be total free flowing text, right? These will be unstructured data, total free flowing text data. Normal one-to-one discussion over a chat window. These are total unstructured data, but I'm going to fetch all the data from my customer care. All right, somebody might have also picked up a phone, called up customer care and conveyed the lack of ATM in a locality. So second one would be, audio files. Get out audio files from the customer care logs. Fourth source can be, I'm sure somebody might be going into social media and tweeting about the lack of ATM, right? So I can go ahead and search for online tweets or online social media data to find out if somebody is actually, facing problems, unable to locate an ATM. Survey. So of course I can go ahead and distribute pamphlets to everybody who comes to my bank and ask them to fill out a survey. Where do they find a lack of ATM in the city? Or I can also have an online survey in my net banking. Every time somebody opens a net banking, I can ask them to fill up a 30-second or a 10-second survey, right? We have multiple sources of data. Data will be coming from multiple sources. If I want to make a rational decision, I cannot rely on making a decision only on one source of data. That will not be a rational decision. If I want to make a rational decision, if I want to really make a correct decision, I have to look into the data that is coming from all those sources and collectively make a decision by looking into this data on a whole, right? A 360-degree view of the data. I have to collect data from all the sources and then make a decision. So my question is, now this is where we have defined the problem. Question is, somebody will say, hey, what can be a solution? What can be a solution which can allow us to do that? Can a database load data from all those sources? It cannot store, right? It cannot store data coming from all the sources and have a unified view. You cannot have it. You cannot have it. So we all agree that this analytics team are limited by the progress of the software technology. They are limited by traditional systems, right? Traditional systems will not allow them to collect data from all the different sources and look into the data holistically. It is impossible. So maybe out of 10, somebody says, hey, I have heard about something called Hadoop. Hadoop is a new technology. Hadoop is a solution that does give two things. Hadoop is a solution that gives two things at the bare minimum. One is, it is a platform where you can load any kind of data, and secondly, it allows you to write processing algorithms on that large amount of data. So Hadoop is a platform that allows you to store all the data that you think about, and it gives you a platform for processing the data that you have stored. So these guys in the analytics team, in that room, they thought, okay, this is a correct use case for big data. So we have identified that, yes, if you really need to have a platform, a solution where you can collect data from all the sources and process it, then there is no other technology apart from Hadoop that can do it right now. Alright, so what this team do is, they collect data from different sources, they store the data into Hadoop, they process the data into Hadoop, and then they create a report in Hadoop. And the report will have maybe a chart saying the most important area or the top of the list area where you need to set up an ATM will be ABC location, and the second in line will be XYZ location. You take the report, you come to the manager looks into this report and says, hey, I have got what I need. Now what I do is, I can go ahead and make a rational decision. My decision would be set up an ATM in ABC location. Next quarter, if I really want to set up another ATM, I would go and say, hey, go and set up an ATM in XYZ location. Alright? So this is how big data Hadoop solves actual business problem. So what does Big Data Hadoop tries to do? Big Data Hadoop tries to provide a decision-making capability by loading and storing large amount of data. All right, so it is a data processing platform that allows you to process large amount of data, irrespective of how much of data you have, in a very fast and timely manner, because you are even not worried about the processing capabilities right now, and try to provide a solution which is used for business decision making. So Hadoop is an analytical software, guys. It is not a point of sale software. It is not a web-based software. It is not a customer-oriented software in that way. It is an out-and-out analytic software. It is used for making or deriving hidden patterns in the data so that the management, the business, can make decisions of the business. It can help the business grow by looking into these stored data. All right, so it is an analytic software used only to ensure that it can help make a decision on the business front, right? So it is a business-driven analytics software. How data like video, images used to store in Oracle before Hadoop? Well, honestly, guys, nobody used to save images and videos in Oracle. What they used to do is, normally, they'll store the images and the videos in a cloud-based system and store the URL in one of the columns in in your database. So database normally do not store images. It's a very bad design. Normally people do not do that. They have an image server. They have a some kind of a public-based cloud solutions where they'll upload the videos and everything they want, and only the URL will be stored into this RDBMS. I've seen people saving smaller images as blob objects, but tremendously slow. That's a very strict no into data modeling, right? So nobody does it. Vyram says, can you analyze audio-visual files using Hadoop? The answer is yes. So what is big data? We all have identified. So Amazon handles 15 billion customer clicks per system, or per day. So basically, if you go into any other, is it possible to view others' question? Yeah, unfortunately, you cannot view others' question, and that is the reason. Every time somebody asks me a question, I repeat the question, I read it out loud. All right. But unfortunately, we cannot. Yeah. All right, guys. So what is big data? So we have been seeing big data in a lot of different places. And if you go to Amazon, you go to Best Buy, you go to any other retail websites, all using big data. Stock market, well, New York Stock Exchange, NCDC, they're using they're using big data for analytics of stock trends. And then 294 billion emails sent over every day. So huge amount of emails sent, and how to filter out the data. So one of the use cases is, imagine that you have a very large company. In your company, of course, will be receiving a large amount of emails. You have to find out whether the email is a spam or not, right? So your mail server have to make a decision whether the email is a spam email or not a spam email. So what do? Right? You cannot open the email in a traditional system and just read the email and see whether it's spam or not. So you have to provide a system which is a distributed system with large amount of processing capabilities, so that on a real time you can find out whether the email is spam or not. All right. So all these are use cases of big data. We're going to talk about the other use cases of big data as we move along. But all in all, what I'm trying to say is, big data is available in your surroundings. When you look up in your surroundings, everything you do, everything you work with in today's world has a big data angle to it already, right? So even though if we think about big data as pretty new, but it has been there for quite some time, and people have been using big data for almost a lot of time right now, and a lot of systems have been developed and have gone live into production with big data. So big data is very stable. It is doing wonders. All of the companies, all of the top 100 companies have already migrated to big data. They are using big data and they're using it for truth. So one thing about big data is, it is not a technology. Big data is a problem statement. Hadoop is a platform. Nowhere we have mentioned that it is a software bundle. Nowhere we have mentioned that it is a tool. So to be very honest, guys, I started my career in big data 5 years back. And if I tell you about the things that I've learned in the last, or I've learned on the first year that I've joined big data, you guys even do not know about the names because they have been obsolete by now. So in big data environment, guys, you have to keep your mind open that every 3 months you're going to think about, you're going to learn about, and you have to upskill yourself into new technologies. So big data is not a technology, it is a platform. In that platform, you're going to have new technologies coming up. The internal architecture, the basic architecture is going to remain the same, coming up as you cannot even imagine the rate in which things become old and new things creep up, right? So in big data world, you cannot just hold on to a past law and say, hey, I've learned about it and I'm going to be pretty okay for next 5 years. No. In big data world, the concepts are important. When you learn the concepts, the services, the softwares, they're going to change every 3 months. That's how it is going on for the last 5 years. Every 3 months, there's something that new comes up. And then data, if you want to be in the technology world, if you really think about understanding the back end of the data system, then big data is for you. Because big data, is not reliable to a particular software. There is not a single software that is associated with big data, whereas it is just a platform, and that platform gives you advantage of learning new things. If your basics are clear, you can learn and get over with a new use case, a new service very soon. So what exactly is big data? So let's look at this graph, guys. In this graph, it talks about the trend of data. All right. So starting from 2005, people have been seeing a large amount of growth in data. Now, if you classify the data, you can classify the data into two different segments. One is structured data. What is structured data? Structured data is the data which is already available in your system. Your relational data system, all your RDBMS backed system, these are all stored in your structured data. If you look into the structured data, you'll find that there is a linear growth of the structured data for last 10 years. Last 10 years, there has been a linear growth of the structured data. If you look into the other phase of the data, they have seen that data has been growing exponentially for last 10 years into this unstructured data. Unstructured data are all the data which are outside the scope of your system but freely available, like social media data, email data, all your internet-based data. Every single data which is outside the scope of your organization are termed as unstructured data. And people have seen that there is a exponential growth of the data. So what has happened in 2005 that you can see that there is an exponential growth in this unstructured data. That has happened in 2005. Facebook went live, social media, yes, the same thing, right? So 2005 was where people went to Web 2.0, where people are talking about all the social medias, all the mobile applications, everything was coming up. So it was a huge boom in the data management systems, right? So starting from 2005, you see an exponential growth in the data. Imagine that you are supposed to make a decision in the business. Your business is supposed to make a decision. Can you rely only on the 10% of the data, guys? Do you think you can rely only on the 10% of the data to make a decision? Will that decision be correct? Probably yes. Probably the decision will be 10% correct. If you're only looking into 10% of the data, 90% of the time your decisions are going to be wrong. Similarly, you cannot also rely on only the 90% of the data. So to make a decision in today's world, you have to rely on all the 100% of the data. So you need to find out a platform that can process structured data as well as unstructured data, that can combine structured data as well as unstructured data. If there is a platform that can load all these kinds of data together, then that decision-making system, that system will definitely help you make any kind of decision that you think about, because decisions are backed out only by the data. So data collection, processing, and analytics can be made sure only when you collect all different kinds of data and process it together holistically, right? So this is the analogy why you need to do big data, one trend of data. You cannot just rely on the structured data or only on unstructured data. You have to combine both these views together and see a holistic view of data. Vyram says, does company give more preference to analytics from structured data than unstructured data? Yes and no. Yes and no. All right. So why yes and no again? We know the percentage. The data that is stored into your structured traditional system in your company, these are only 10% of the data, right? These are only 10% of the data. But most importantly, these 10% of the data are all genuine data, very important data. Whereas the other part of the story is 90% of unstructured social media data. So although the number is 90% relative data, from that 90%, when you have to crunch down the numbers, when you have to analyze the 90%, you will see that it is only 20-25% of these 90% that makes sense to you, right? So all in all, a company has to give equal weightage to both, but unstructured data will have to be analyzed more, because you do not know what value that data stores, right? Unstructured data, social media data will not have large amount of value. It will have limited amount. Compared to 90%, the data value will be very less. Whereas the 10% of the data, these are all actual, really important data. So whole in all, you cannot rely on only one phase. If you think 90% is good enough, I can ignore my internal data. Well, no, you cannot do that. Similarly, you cannot just ignore social media data. So I'll tell you a story, guys. Again, another story. Now, imagine that, imagine, Byron, you go to a local shop that you have been going for last 10 years. So Byron goes to a local shop that he has been visiting last 10 years, and he wants to buy a bar of chocolate. He really wants to buy a bar of chocolate. He goes to the shop and he searches for a place where he goes and buys that, picks up that bar of chocolate. So every user who uses the system has an intrinsic and an extrinsic need. What are the extrinsic needs of Byram? What can be the extrinsic need? Simple, right? The extrinsic need is the chocolate. Yeah, the bar of chocolate is the extrinsic need. He has gone in for buying that only. What is the intrinsic need of Byram? Intrinsic need would be, because he's been going to that shop for last 10 years, he thinks that the store owner will at least say, hey, Mr. Byram, how are you doing today? A one-on-one relationship. Or he can say, hey, Byram, I have this store counter open. Even though there are a couple of people in the line, he says, Byram, can you come here? I can quickly bill you up. Intrinsic need is, he wants to get a personalized touch from that store because he has been frequenting the store so much. If I've been going to the same shop again and again, I expect that the shop owner gives me a little bit more than anybody else. That is the difference in today's world. You cannot just keep your customers, happy only by fulfilling their extrinsic needs. You have to cater to their intrinsic needs. You have to understand what they want before they come and tell you. That's what Apple has been doing, right? So Apple has been going and becoming such a huge industry right now, company, because they give something to you before you go and demand it. That is the reason they have such a good and such a loyal customer following or customer base, because you're thinking about the customers first right now, right? So in order to find out that intrinsic need in today's world, when people are talking about online based, shopping and all, intrinsic needs can be found out only by looking into your social media and other data which is outside the scope of your system, outside your relational world. Your relational database will have extrinsic needs, who has bought what, but your intrinsic needs can be only found out from outside the organization, which is of course from social media and all other things, right? And that is why you have to combine your extrinsic need data, which is social media data, along with extrinsic need data, which is relational data, and combine these two and find out the analytics so that you can cater to the customers better. So no data is important, no data is unimportant. Everybody has to cater to customer need. And it will come from both these sides of the story. It has to come from relational world and it has to come from a non-relational world also. All right. Now you guys know big data. You have heard about stories of big data. I know you have been now thinking a lot about big data. We imagine that all of us are here to become tech archs in Hadoop, right? So we want to become technology architects in Hadoop. Imagine that we all are technology architects in Hadoop. We go to a client place, and the client says, "I have business problem." So what do you say? Do you say, "Hey, I know Hadoop. I do not need to know your business problem. Go with Hadoop"? Are you going to tell customer that they need Hadoop no matter what problems they do have? Probably not, right? You have to find out whether Hadoop is the best suitable fit for their business problem or not. You cannot just go and propose Hadoop to everybody. It is not the way, right? You have learned Hadoop, now this is the latest technology you are learning. If anybody says, hey, I have a problem, you say, hey, Hadoop is a solution. You just cannot go and propose Hadoop to everybody, no matter what problems he has. Somebody says, my email is not going to my manager. You say, use Hadoop. Now, you cannot do that, right? All right, guys, so point is, how do you know if a business use case is a Hadoop use case or not? So IBM says there are 4 different ways of categorizing or tagging your problems as big data problem or not, right? If you can tag these problems that your clients say into one of the 4 vertices, then probably these problems are big data problems. The first one is volume. If the client is saying that my data volume is so much and my data is growing so proportionately that I think traditional systems cannot handle that amount of data. If the client says that my data is growing humongously, and in a couple of months I cannot even imagine where I can keep the data, then Hadoop is the solution for you. So if the problem is associated with volume, then yes, Hadoop is your solution. Second is velocity. Velocity says if the rate in which the data has been ingested into your system is so huge that your small system cannot handle that volume, that velocity of data, then Hadoop is free. If you write a web service, how much events the web service can take per second, guys? Not more than 100, right? So it cannot handle more than 100 requests coming, and there is a sensor which is keeping on sending you data. So nowadays people are talking about IoTs, Internet of Things. They're talking about sensors into everything, they're putting sensors into everything, and they have been, pushed down every second. If somebody is sending you millions of events per second, do you think there is any traditional system that can handle that amount of data coming in? No. So if the velocity is the problem, if the data that has been retrieved is so huge that it cannot be processed or cannot be handled by traditional technologies, then Hadoop is definitely for you. Variety, if you want to make a decision and you know that the decision will be based out of a lot of data and the source of data is varied, and the source and the data itself is also varied, like you have audio data, video data, log data, text data, CSV data, TSV data, you have different kinds of data. If your data is varied and you need to process them together, that's the end of the story. You have to process them together. Then you need to have a system which can handle, process and analyze this variety of data together. So if variety is a problem, then big data Hadoop is a solution. And then veracity. Veracity says if the data that is coming from, unsure about if the data is correct or not. So you cannot save the data. So veracity says if the data that you are pushing in, the data might not be always correct, because you are also talking about data coming from all those external sources. You're not sure about the structure of data. You're not sure if the data is correct all the time. So veracity says trust the system. If you are not sure about the kind of data you have, you can still load the data into your Hadoop-based system. So veracity says, and net about veracity is, in today's world, guys, normally if you talk about a transactional database, any database you talk about, every data have a shelf life, right? Every data have a lifespan. Normally, every year, older data will be archived into a tape, right? You're going to archive the data into the tape and lock the data away. But in today's world, you cannot just lock away your data, because data is the most important thing for you. Data is like gold dust. You cannot throw away the data. So Hadoop veracity point says you trust Hadoop with the data. Hadoop says Hadoop is built out of commodity hardware. So we're going to talk about commodity hardware later on. Hadoop is normally based out of commodity. So the net important part is setting up and maintaining Hadoop cluster is very, very economical. The money you spend on setting up and maintaining a Hadoop cluster is quite comparable to maintaining and managing your tapes. So Hadoop says do not throw away your data. Do not lock away your data. Instead, if you think that you want to archive the data, push the data into Hadoop system and you run analytics on the system so that the data is not wasted. If you have 10 years worth of credit card history of a person, you can create models and see and create a fraud detection model maybe. So important thing veracity says, do not throw away the data at any point of time. Do not lock away the data. Use the data for analytics purposes. You use the data and push the data into a system, into a Hadoop based system, so that later on you can do analytics. If you are not allowed, if you are not thinking about analytics at this point of time, use Hadoop only for storage, but tomorrow you can go ahead and run analytics on that. So veracity talks about the value of the data. It talks about the trust of the data, and it talks about the ease of which you can load the data. So even if your data is corrupted, if your data is not correct, still load the data, because you're not supposed to throw away any data, right? So if your client talks about his business challenges and he falls under any of the 4 vertices, which is volume, veracity, variety, and veracity, then you can go ahead and propose him saying that, hey, you need to have Hadoop as your solution. How veracity is different from validity? Well, validity is a common term, right? Here we're talking about the 4 vertices of tagging a problem. So here the veracity problem is you are supposed to archive your your data at let's say after every year. you are doing this process, right? Everybody archives the data. Your transactional database cannot handle years worth of data. You have to archive the data. Hadoop says, hey, do not archive and throw away your data into tapes, because if you load the data into tape, you cannot use them again. So do not throw away your data. You move the data into Hadoop. Use Hadoop as an archiving platform so that anytime you want, you can run analytics on that data. What kind of data it can be? It can be 10 years worth of your credit card data. Imagine how important that data would be, guys. 10 years worth of a customer's buying and selling patterns or buying patterns in credit card. So Veracity says, trust Hadoop with the data. Use Hadoop with data. Do not throw away your data.